No, it just switched from off air to live.
Okay.
Casey.
Well, good timing. You called it right when a whole bunch of people joined. So that's good.
Hey, Jack.
Hi.
So I realized after our discussion last week that the propositions don't have to be bets, right? They can be, the bets can be only on the maximally consistent subsets.
What do you mean the bets can only be on the maximally consistent subsets?
I just mean that when the betting behavior is only on the maximally consistent subsets. The propositions are sort of, you can think of propositions as stand-in for blocks.
Yeah.
Right, and then you can incentivize to get the most propositions by using the justification structure for the maximally consistent subset, say exactly, which proposition set this is drawn from.
Sorry, you want to talk about the justification structure for the maximally consistent subset?
So for me personally, the maximally consistent subset is pretty simple. It's just every block gets in.
Well, that couldn't quite work, right? If there are collisions, right?
Yeah, exactly. So basically, we're gonna have
if one validator equivocates.
No. As in, some of the bets, there's not the bets haven't yet converged, and so we have a whole bunch of different sets that we can pull out of this, basically set of propositions with weights.
Oh right, yeah, I see. So, okay. So I guess I'm trying to be much less abstract because I see these propositions as being pretty simple. Like block X gets in or block X doesn't get in.
Yeah. Oh yeah. Right. But what about X versus X prime? I mean, that's the other option.
Yeah. See, so I'm actually deliberately trying to avoid block versus block scenarios precisely because of some of the.
Sure, but you can't stop a Byzantine node from causing that scenario.
Well, no. So what you can do it. Well, so. Okay, if a Byzantine node equivocates, then yes, you have X versus X prime. But Byzantine, so yes, that has to be decided. Though on the other hand, you can't force Byzantine nodes to create competition scenarios between other people's blocks.
And then the other thing is the way I'm looking at it. If you look at the logic paper, the propositions can see into block structure, so it's not just at the block level; it's at the transaction level.
Right. Okay. So that's post 2.0 stuff then.
And then for let's see, and then Vlad raised a very interesting point, which is unless you have isolation information, then it's hard to make certain decisions around that. But I argue that because we control the namespace, or essentially the address space, that should be sufficient to use static analysis to infer isolation and dependence amongst the contracts.
I don't really think that works because contracts. So say that I have two contracts, two different addresses, each of which call some contract from their storage, and one of the calls from one of the contracts to the other would change that piece of storage that would change what call the second contract went to.
You can actually follow that. That's why I was giving you the references to Mads Tofte's work on region analysis and similarly the separation logic. That was.
What I'm saying is that it's not static.
It is static in the sense that you don't need anything more than the information of the contracts. So if a contract is in storage, then of course you'll have to ask for the contract in storage. But what you'll be able to detect is that there is the possibility of intertwining or interdependence.
But only by executing the contracts.
No, you don't have to execute the contracts. That's the point. Is you can do them. You can execute it symbolically.
Yeah, so I'm not sure if that's true because of the fact that you can put together addresses that you send calls to on the fly based on some arbitrary script.
If addresses are put together based upon input from the outside world, I agree with you.
Yeah, which you could do.
Yeah, that's correct. And there certainly will certainly, if it is the case that an address is calculated from arbitrary code, yeah, right. That's halting hard. However,
Right, yeah.
you can do lots and lots. In those cases, what you do is you punt and you assume the worst.
Right, and which means that you get what does that mean?
You assume that there's a dependence. So you say you can't isolate those.
So what are we trying to do with the with isolation right now?
So then with isolation information, what you can do is you can say whether or not essentially two propositions that have to do with two different contracts, transactions against two different contracts can commute or not.
So you get a whole bunch of efficiencies around like the convergence of the bidding cycles.
Exactly. So correct. That's
okay.
Right.
I think that is really cool, but I do also think that is like, something that. Yeah, I mean, I think it's really cool. I'm not sure if it's the simplest thing to implement, but if you feel comfortable with that.
What was the exact proposal again?
Well, so I mean, if you basically might be able to do static analysis and maybe not, and if you can't, then you assume the worst, and if you can, then you will have an easier time converging on the state, because you'll know, for example, that these sets of transactions can be converged on independently from those ones.
Right. So
I'd personally rather kind of try to incentivize users to provide that information directly.
But users don't necessarily know what contracts their transaction is going to affect.
Well, sure, but the protocol doesn't know that either ahead of time.
Right. So if the user can give them information, that would be cool.
Yeah, of course. And if we use type declarations, then all more is the better, right?
Yeah.
Right.
But,
so then that becomes even.
Right. But then we need to be in and choose the VM to be a typed one, which it's something that is hard for us to commit to at the moment. But
I mean, types can mean lots of different things. Like the simplest possible thing is what we're already planning on doing, which is letting transactions declare address ranges that they're restricting themselves to.
Hey, we're most of the way there towards what I need.
That's interesting. So say I make a transaction that restricts itself to an address range, and then it tries to go outside the range. Would that throw an exception?
Sure.
Oh, wait, but the important thing is that you detect that exception. That's a compile time exception, not a runtime exception.
No, so it is a runtime exception potentially, because what you could end up doing is you could end up having some variable that's an address which is dynamic and I mean, I think just making it an out-of-range error is pretty safe, because if people basically means that nothing happens.
So it's not really a type.
Yeah.
Right.
Well,
right.
No, okay. it's like a range restriction that's attempting to help. Well, it is helping convergence, because you can converge on two different sets.
It's more like an assertion than a type.
Okay. No,
that's right.
That's fine.
Cool. That makes sense.
Yeah, I mean, I kind of like the assertion thing, but as long as it's not required, right? I don't think that we should require this from clients. Although if they were to give it, maybe that we could give them a gas discount or something. But then that starts to get complicated.
Yeah, that's basically what I'm planning on doing. Yeah, in general, one thing I'm not gonna compromise on for 2.0 is that everything that was possible in 1.0 should continue to be possible. There might be expanded address ranges between which it's not, but everything on the existing space should continue working as it worked before in the existing space.
So then also with respect to implementation stuff, one of the things I've started to give developer workshop talks on how to take some of these concepts directly to code. So this past Friday I gave a talk in which I described how if you work with parameterized abstract grammars, then these correspond directly to type declarations in most functional languages, and talked about a tool called BNFC that allows you to go directly render this directly to both in-memory data structures and on-the-wire data structures. And the next step there is I'm talking to Roman about his Java-based implementation to see if we can simply plug in because using the BNFC, I can take this data structures as spec'd in the logic paper and go straight to code for in-memory data structures and on the wire. And the advantage of that kind of development methodology is that, again, it's correct by construction. Every single thing follows directly from the math. So we're not the weakest link, of course, will be whatever programming platform you're sitting on. But again, you go straight from the mathematical spec to running code, and the code is there's you have a chain of proof that everything follows directly from, and so whatever theorems you enjoy at the higher level spec, you enjoy at the lower level spec. So that's another piece of work that I've been pushing out with respect to the Casper stuff, because I'd like to start getting this implemented.
Sure, but I mean, like, we could do a lot of this stuff even without types at all. I mean, pretty much all of it. It's just like less efficient, right? I mean, and I mean, the main thing, like Vitalik said, is that we need to be backwards compatible. So we can't insist that this stuff be available for all contracts, all data structures.
Make it an option and even incentivize it with cheaper gas costs.
Yeah,
that's totally fair. I think it becomes of value to Casper and to Ethereum, though, to have a kind of clean room implementation that isn't beholden to, a 1.0 stack, because that way you can kind of push the limits. You can use that as as a kind of a straw man to.
Sure, but some things can be transpiled and like still maintain a nice implementations, and whereas some things like like the type thing, like you don't get to have types if you didn't before when you initially deployed your contract.
No, that's exactly right. That's correct.
And so I would say that it's like that's tough. That implementation complexity is our technical debt, and if we want to get rid of it, then we have to basically we basically either need to break this rough social contract or hard fork, or meaning start a new blockchain.
Yeah, no, exactly, and this is kind of what I've been why I tried to get in, as soon as I possibly, once I sort of figured out what you guys were doing, I tried to get in as soon as possible. I just would love to have, formal methods influencing the development methodology from the get-go.
Yeah.
But there's two levels of the development methodology, right? There's the development of the protocol, and then there's the protocol itself, and then there's all of the contracts and applications, right?
Yeah, exactly.
There's an extent to which the protocol is given by what we can provide for applications, but we already have some applications on there. We can't really stop servicing them.
No, I hear you. It's always a tricky game to play, right? If you've got legacy code, it binds you in a certain way. And personally, I don't think you have enough there that hard fork is not going to be it's not going to be much lower cost over time than the maintenance fee.
Sure. But the other thing about requiring types is that it increases the burden on the contract developers. And
unless you have some kind of type inferencing.
Oh, interesting. Type inferencing. Oh, that's something that I don't know about.
So a really good example is Hindley-Milner, which is what they use in Haskell, where you can infer the types of functional programs. It becomes a lot harder. Type inferencing in the concurrency setting is much more complicated. There's a system called Typical that was developed by I'm sorry, I'm blanking on his name, but I can look it up. That does do type inferencing for for the concurrency setting. I mean, in your case, you guys essentially have a sequential machine, so you can just use, you know, Hindley-Milner or some variant thereof. In the case, in the kind of VM that I'm imagining, type inferencing would be more subtle, more nuanced.
Okay.
But isn't Ethereum transition to a concurrent execution model as well?
I would hope so, but I'm not sure what the actual plans are.
Well, I mean, certainly execution will definitely. I mean, sharding, like any scaling solution, is going to have concurrent execution. The question of whether or not the core of the EVM will be like based on the pi calculus, I think, is still open.
Yeah.
Well, it doesn't have to be based on the pi calculus. That just happens to be the best concurrency calculus for this kind of stuff. But you could easily base it on lots of other things as well.
Sure. So how about, let me try to rephrase. I don't think that we have consensus on the idea that we will use a VM that's designed for contracts to be easily formally verifiable in the concurrency setting.
Right.
Yeah.
Which, you know, I actually, like, to me, it sounds like a no-brainer that we would have this option, but it is like absolutely no-brainer. I mean, I want mission-critical applications to be deployed to the blockchain. I want it to be like secure enough, and formal verification is like the only way to really do that. But at the same time, I don't making it mandatory. I feel like
like the analogy that I used in a Reddit post is that it's kind of like blood types, where, you know, if you're giving blood, you want to have type O blood, so you can kind of you can give it to everyone. But if you're accepting it, you want to have type AB, so you can accept it from everyone. So to me, like, the current not verified at all Turing complete like virtual machine is kind of like type AB, because everything can compile into it. So, you know, whatever trade-offs developers want between ease of development, programming style, whatever, they can do it. And with higher level languages, that's the place where you might want to have more restrictive systems, possibly of different kinds. And
but you don't want to have a proof obligation to show that the compiler to this, like,
exactly. You don't want to have any obligation at protocol level to be kind of provable. Like, I think it should be sort of done in a high level language systems on top.
No, I mean, you'll have to prove that the high level thing that can be verified compiles down to the low level thing.
Oh, right. Yes, correct. You'll need to, if you want to kind of be purist about it, you'll have to write a formal verifier that, proves that the properties at the high level sort of inherit down to the low level.
Yeah, you prove the correctness of the compiler, and then you have to prove the correctness of the virtual machine.
Right.
Which is my understanding is that that's harder to do than to design the VM from the start with that in mind.
That's correct.
The question,
you have different requirements.
Say that again, Aaron. I couldn't hear you.
Could you have different requirements for different shards? I mean, like you have one with
yes,
maximally identical, but
so I mean, this is like to the maximum extent we should try to not have the developer reason about different environments that their application might be sitting in. Like, to me, it's like ideal that like, at least for the first sharding, that we don't have different environments.
Right. I mean, if there are areas where, you know, there are inevitable trade-offs, then we should make it kind of possible to express the trade-offs, but it should be as simple and ideally low-dimensional as possible.
Yeah. So I mean, I've kind of
sort of.
Go ahead.
Like, for example, maybe like providing different levels of security on different shards.
Exactly. Yeah.
But that's like.
What?
Sorry, I didn't catch that, V.
I was just going to say, yeah, that's. I mean, it's a good example, and it's. I forgot what other point I was going to make.
Oh, but you weren't objecting to my idea that 3.0 or 4.0, not 2.0.
Yeah.
Oh, sorry, we're talking over each other.
Mm-hmm.
Well, I was just going to say that I'm sort of aware of the exigencies of the Ethereum situation. So that's kind of why I want to do a kind of clean room implementation, where we do have a correct by construction VM, we have a correct by construction compiler, and all of those things. And then that doesn't have to be, people can just play with it, right? We can just put that out there. It can be open source, and people can play with it and see, why. It doesn't have to be. It doesn't have to be the accepted Ethereum stuff, but it can certainly serve as a pedagogical device.
Mm-hmm. I mean, that's obviously always going to be wanted, right? The question is, how can we get the benefits of this formal verified stuff in the main Ethereum blockchain without losing the backwards compatibility that we basically can't compromise on.
Yeah, and I think that it's I mean, since Ethereum 1.0 is Turing complete, right? We can certainly make a transpiler from one VM to the other, and that and you prove that you can prove that correct up to the assumption of the correctness of the EVM 1.0.
Yeah.
And that would be sufficient.
Execution, right?
What's that?
But that'll do the execution, not necessarily the types, right?
That's right. So the idea would be that you have types and correctness down to this. Let's call this the Pi VM. Okay. So you types and correctness all the way down to the Pi VM, and then you do a compiler from the Pi VM to the EVM 1.0. Right. So you get correctness all the way down, including to the surface area of EVM 1.0, and then all bets are off.
So why would we want to run PyVM programs on the EVM? Isn't it the other way around that we want to do it?
So there you could, yeah, I agree. You wouldn't necessarily want to target that. You could certainly also do a cross compiler from EVM to PyVM. You'd have to do type inference.
Exactly.
Right, but so why can't we why do you think that's necessary? Do we need we don't need types that badly for for it to work?
Yeah, you don't ever need typed execution. That's not you can always do untyped versions of typed things. It's just that ends up being much more costly over time.
Agreed. Yeah, and so there could be that could be more expensive as a result of that, right?
Yeah, exactly.
So that's more or less fine. The thing that I worry more about is, I guess, one other goal that we kind of have is for all these different implementations to be able to follow suit.
Yeah.
Follow suit. What does that mean?
Meaning implement and sync up with whatever is the reference implementation. And I mean, I'd like the idea of having the reference implementation be as formally verified as possible.
Yeah, I agree. I think the reference implementation being formally verified would be the gold standard for the community.
Mm-hmm.
I still think the reference implementation should be in English.
That could be the top level spec, but I mean the
right.
thing that people will reference when they're writing an implementation should be verified.
So
I think people reference English when they write an impimplementation.
I have a short little story about specs in English. I wrote a ATM network management system for Sumitomo Bank, and I wrote it in a reflective language, and they suddenly wanted in English documentation, so I took the weekend and I wrote a code to English translator.
I'd like to see the output of that.
And I ran it. I ran it on the ATM network management system code, and then delivered the English spec.
Mm-hmm.
And because I was delivering it to a non-English speaking culture, they were perfectly happy with that.
Yeah, I mean, I can totally so there's what I would like to do is be able to take the English spec and like translate it into things that can be proved by like a machine.
Right.
And also, the important thing isn't so much it's like the idea of verified code, right?
Right.
There's verifying the because it's the properties.
Mm-hmm.
And
You still there?
like just analysis, but then there's like actually verifying that the code has those properties.
Right.
Yeah, that's correct. and we want both levels, right? We want like proof of convergence, and then that the implementation matches the spec.
Mm-hmm.
Yeah, I think that would be great. The question is like like formal verification obviously comes at a higher cost in terms of understanding and labor, but I think that is like probably worth it.
Mm-hmm. So can we just move on to a bit of a different section, some practical issues that I've come up with around Casper.
Great.
So one of them is this issue of so basically the idea is that validators actually have an incentive to delay creating blocks as long as possible because that lets them grab more transactions and get more fees.
Mm-hmm.
So I'm wondering if there is any way around that, any way to mitigate that effect. To what extent is that effect bad?
Well, I mean, the blocks fast as possible approach mitigates it, right?
Well, no, but the problem is that you don't have it. So, okay, so let's say you have a blocks as fast as possible approach, right? Then let's say you have some time limit between, after which if some validator doesn't show up, the next validator can show up in place of them, right?
Oh no. So that validator can play some. I mean, there's like a default strategy about when you start betting aggressively on the other guy's block, but that guy can publish his block. As soon as he has an inkling that he suspects that this other guy isn't online.
I don't know. That feels a bit too.
I missed the concern. What is your concern?
So the concern is, suppose that practically speaking, a validator has an incentive to publish a block, within some period of time. Then, if that validator actually has an incentive to delay publishing the block a bit, because publishing the block a bit will increase the amount of time that validator has to collect transaction fees.
Yeah, or to pick out the transactions that like give him the most fees out of the ones that he has available.
Yeah. So if the gas limit isn't filled, it's about the most transactions. If the gas limit is filled, it's about maximizing revenue.
Yeah. So that's definitely true. And the only thing that is like disincentivizing them is their probability of their block not getting in.
Right. But the problem is they don't want to rely on that mechanism, because if you make that mechanism strong, then it creates a high incentive to be able to have higher network connectivity, which you really don't want because of the centralization risk.
So to me, I do analysis of centralization based on like the kind of like disincentive of like a cartel to exclude the non-coordinated.
Yeah, I'm trying to prevent cartels from forming in the first place.
I just assume that they'll form.
I think they can form to a greater or lesser extent. I think you both have protection.
So, there always is an incentive for everyone to get their machines closer together because then they're better.
Well, I'm actually trying to make that incentive be as low as possible. So I'm trying to create a system where as long as the network time is reliably below 4 seconds, then you get basically about the same rewards no matter what.
Okay, so basically by using time.
Yeah.
Like in order to like more specifically like schedule when validators are allowed to produce blocks.
Yeah.
Like that is your strategy for doing that.
Mm-hmm.
Yeah. So naturally they're just gonna have an incentive to publish blocks at the end of their period.
Right.
Or as close to as close to over as they can get it.
Yeah, and I guess you could make the case that if a validator has stronger sort of network knowledge, then they can time themselves closer to the end of the period because they have a better idea of the trade-off between publishing later and not getting included.
That's true, but what I'm saying is that if your strategy is, to prevent centralization is to give people scheduled time, then like they're
Then we're
definitely
going to try and publish toward the end of that. Yeah, and like theoretically, I'm fine with that.
But you just raised it as a concern.
Well, no. So my concern basically is that I'm fine with it theoretically, but the thing that annoys me basically is the fact that in that kind of environment, there is still an incentive to have better network connectivity, because if you have better network connectivity, then you can go even closer to the end of your time slot and still be sure the block probably gets included.
And I mean, honestly, like I personally feel like it's a good thing to incentivize having better network connectivity, because I don't think that that's actually like the main force of centralization in like this protocol.
I'd argue. I mean, if network, it depends on how much network connectivity affects profits.
Yeah, so it does, but it also affects user experience, right? The more connected the validators are, and the less they like have hiccups, the more quickly my transaction receipts get finalized.
Right. Yeah. No. So I think there's a trade-off between like centralization risk and how.
Convergence speed.
Yeah. Exactly. I mean, it's true for proof of work. It's true for I think any system.
Yeah, and I think that's true, but I think that the main source of centralization actually is in the incentive of the cartel to behave badly.
If let's say we deal with that reasonably well, what's the next major source of centralization? And I'll also keep an
briefing attacks.
What kind of attacks?
Briefing.
Waiting.
Griefing.
Oh, griefing. Okay, so
I would say cartels, then griefing, and then maybe operational costs and network stuff.
Okay, so I'll give the practical piece of so empirical evidence, which is that we have seen centralization, happen in Bitcoin. We've seen mining pool centralization happen in Ethereum, and in generally that happens for a couple of reasons. So one of those reasons is just, well, in the proof of work case, or in the proof of work mining pool case, it's because bigger pools can provide lower variance, and I would argue that some of it also is that if you look at some of the different mining pools, quite often these different mining pools end up having different fail.
Oh no, you're breaking up. I'm not sure if you're breaking up for everyone.
Are you hearing me better now?
I've been hearing you fine the whole time.
Okay, so the other challenge is that one thing that actually happened, for example, is that the person from each pool, I think, put their mining pool server in the same data center as a dwarf pool, and that managed to reduce his uncle rate to some extent. So this stuff does happen.
Yeah, but I think that it happens more in proof of work than in proof of stake, because that you don't actually benefit from excluding other people's blocks. No,
the thing is that even in the case of proof of work, it's not about excluding people's blocks. Like, none of these mining pools have so far actively engaged in a strategy of excluding anyone. So far, all that they've done is they've tried to situate themselves closer to each other in order to reduce their uncle rates.
Yeah, exactly. So they want to reduce their uncle rates. They're not necessarily trying to increase other people's uncle rates.
Mm-hmm.
Although they may actually be doing that indirectly, because other miners won't be close to the center.
Well, no. Well, because okay, so in general, right? If A moves closer to B, you can't. That's going to make C further away. The question of whether that makes C further away or closer to A is completely indeterminate. It could be either one.
Right, exactly. So some nodes, for some nodes it'll be.
Some nodes will be closer, some nodes will be farther. So I'm just arguing on average that the effect of that is kind of neutral. But
but in Casper, it's much more cut than that.
Yeah, in Casper you have stronger incentives not to do things that increase other validators' uncle rates. I agree.
And to me, I want to say that that is enough to mitigate all of these risks, to my satisfaction.
Not to mine.
And then because what will happen is that the cartel will move close together, and then the non-coordinating members won't be so close to the cartel's network, and the cartel won't have an incentive to exclude them.
See, if you're comfortable with the cartel, then you could just, give up this decentralized consensus thing and make a fidelity bonded bank.
No, that's not right at all. I want I want a market that has consumer guarantees in an oligopolistic setting, where like cartels can't happen. And I mean, I think that we can actually do that. I mean, like, I don't think it'll be possible for cartels to center and revert, or
Okay, I think that's in general, having a market that provides better properties in an oligopolistic setting is good, but I'd argue avoiding oligopolistic tendencies or mitigating them in the first place is even better.
I think that they're inevitable. I mean,
well, they are, but the question is, are they greater or smaller? Because it is an empirical fact that, in Ethereum, you need 2 pools to get 51%, but you can't do it with 1 pool. If you go down to the level of individual miners, even in Bitcoin, it's an empirical fact that you need like 4 or 5 of them to get 51%, but you can't do it with 1 of them. So centralization can definitely get better or worse.
Agreed, but like the protocol really only makes it worse in as far as it has adversarial incentives.
Well, no, the protocol can make it better or worse in 2 ways. One of them is it can have adversarial incentives. One of them is that it can have incentives to coalesce. So if it creates incentives to coalesce, even without the adversarial incentives, then, Ant's pool has the incentive to buy F2 pool or whatever. Or, they have an incentive to merge or co-locate in one.
Co-locate or something, yeah.
Yeah.
Yeah, and I definitely think that is concerning, but the thing that I want to be able to do is to say that, like, if there are some people who are just like looking out for the health of the network, then they will be able to like have, servers in different countries, and their blocks will be included, and they won't be like kicked out.
Yeah. If people are looking out for the health of the network, then in general we should strive for them being able to participate and earn above 0 revenues.
And even if they're not in the cartel.
Yes, correct.
Yeah, and even if they only make up some relatively small portion of the overall bonded stake.
Okay, so in general, the way that this sounds to me basically is that there isn't really a good way of kind of making transaction fees, I suppose, irrelevant, removing this incentive to wait longer to get more transaction fees.
Well, how much?
So I mean, you can definitely reduce that incentive, but what you can't do is reduce the incentive to co-locate.
Okay, so how can you reduce the incentive to wait longer to? Just having a countervailing incentive to produce faster.
Yeah.
Yeah.
Okay, so see, what I'm trying to do is I'm trying to kind of make all of these incentives sort of as close to 0 as possible within the acceptable range.
But making blocks fast as possible has another goal, which is that, like, if someone's offline, like, clients will get faster confidence.
That's agree. Yeah, no, it improves the user experience. Yes.
Yeah.
But
so like that's another reason why, like, so ideally, like, as a validator, you should be like terrified of waiting more than some amount of time, and to me, that amount of time shouldn't be given by the protocol. And I guess to you, you're okay just giving that in the protocol.
Yeah, no, I mean, I'm happy just picking a number and saying, like, what I'm happy with is the idea that we have a synchrony assumption, and I'm just throwing out 4 seconds because it seems reasonable, and me being able to make a claim that within that synchrony assumption, on top of convergence guarantees, we also have some of these sort of anti-centralization kind of market, sort of payoff linearity guarantees.
So what about if a client broadcasts a transaction request to a bunch of validators, then the validators would, of course, be incentivized because a block may be proposed that includes the transaction from some other validator, and so they miss out on the fee.
Right. So this implies that blocks are in competition to some degree. Which is okay, yeah. So it sounds to me like in an environment with transaction fees, avoiding competition might be a bit harder than I thought. By the way, I'm gonna have to drop out in around 15 minutes or so.
Yeah, I need to leave in 15 minutes too. So here's a question: the penalty for skipping blocks, therefore, should be an order of magnitude higher than the transaction fees?
Um, is this a penalty that gets applied to the producer who skipped, or to everyone?
That's a great question. I mean, the penalty is applied to everyone, but what I guess what I want to do is to have the incentive, my incentive to.
So Vlad, I think one thing we might want to do to try to parameterize things more is, by default, let's say that all penalties and all rewards just go to a single person who is, responsible for whatever activity triggered those penalties and rewards. And then on top of that, we have a separate factor. We can give it some fancy Greek letter. We can call it Omicron because nobody likes Omicron otherwise, and you probably right? And basically, you take the average fees and you multiply that by Omicron, and you distribute that minus some constant to all of the validators. So the theory is that if Omicron is if Omicron's some positive constant, then if some minor loses 5, then everyone loses, I don't know, 0.2 or whatever, or proportionally multiplied. So there might be a loss of 2 or something split among everyone.
Okay, so if the penalty for penalizing would be, sorry, for skipping blocks would be like concentrated on the guy who skipped it?
So the idea is that if there's a penalty so the minor who skipped would be penalized, let's say X, and then there would be a penalty of X times Omicron that would be kind of split among everyone.
No, I really am not happy with that.
Why?
Because I want the minor not to have an incentive to wait. I want him to
No, completely. Yeah. So the idea is that if a minor skips, then they get penalized, and so the minor doesn't have and it has an incentive not to wait too long.
And if it gets skipped, it gets penalized, right? But if you skip, do you get penalized?
Oh, I see. What do you think? I'm fine either way.
To me, the effect that I was hoping to use is that everyone would make less fees. Because the thing that I'm doing actually is I'm distributing the fee from a block to everyone who's converged on that block.
Okay, so if we have this Omicron parameter, then everyone gets less fees if there's or everyone gets less revenue if there's a skipping.
But because of the person who lost money for being skipped.
Exactly.
Okay. So that could be fine. So as long as that, I think that's actually quite nice. So as long as that fee is an order of magnitude greater than the transaction fees, then you really will not want to have your block skipped.
Right.
And so you'll have an incentive to publish it, well inside your range.
Right.
Right. And so this is exactly the kind of thing that I am quite comfortable with.
Okay. Yeah, I mean, the other thing I'll think about is well, actually, I'm not even sure. No, never mind. It probably isn't possible. Okay, no, that's fine. I also discovered one issue with private randomness, so which is basically that particularly if you start relying on private randomness for sharding, then there's the possibility of kind of coordinated stake grinding attacks where the goal of the stake grinding isn't to influence total revenue. The goal of the stake grinding is to make sure that everyone gets the same result at some particular height, and so you actually do manage to overwhelm one particular shard.
But wait a second. So with private randomness, this whole conversation that we just had doesn't mean nearly as much to me because you can't actually tell if someone has a right to produce a block until maybe they produce a block later.
Correct. So with private randomness,
so is anti-DOS the main reason why you prefer private randomness over?
That's one of them. The other one is it's generally more parallel. Yeah, anti-DOS is one. The other one is more parallelizable. The third one is just get the intuition that it makes it harder to plan selfish mining attacks.
Okay, but the round robin it's very easy to see why it punishes selfish mining attacks. Much easier to see actually.
No. I mean, the problem is that you know ahead of time when you're going to have particular heights, when other people are not going to have particular heights, and so there might be weird situations where you know exactly that within these 20 blocks, at this point, I'm going to be able to force the consensus in one direction. I'm going to punish the validators before me who might have pushed the consensus in another direction. Whereas with private randomness, you see what you're going to do, but you're not going to see what other people are going to do.
Sure, that's fair enough. But with private randomness, the disincentive from censoring is less direct, right? You can't just
Oh, I see. Because you can't. Well, I mean, in general, you can still. actually, here's the thing: when you if you produce any block, you have to reveal your hash, and that hash reveals all of the previous blocks you could have produced.
Right. So if you only when you produce a block at a later date does it become clear that you might have been censored at a previous date.
Yeah, and I think that's fine because everybody has to wait 4 months to get their deposits back anyway.
No, I mean I think that sucks because like it doesn't punish when there's actually a censorship attack.
Who cares if I get
like,
punished sooner or later, as long as I get punished for it before I get my money
No,
back.
in an actual censorship attack, they won't ever get punished because they'll actually be censored.
Oh, right, I see. Well, no, but the thing is that they're never going to be able to get their money out. Yeah, basically, let's say in order to actually withdraw, you have to provide your original seed, and only then, do the rewards properly get calculated.
Okay, and if people don't withdraw, then everyone gets punished for it?
Sure, that's an option.
No, it's not. Not if you let people withdraw at any time.
Hold on. So people can withdraw at any time, but they have to wait 4 months to get their deposit, right? Isn't that the model we were going with?
And then in the meantime, like that hash, either some of the hashes are ponied up or they're not, and if they're not, then
Exactly. Yeah.
okay. So that I'm comfortable with that still gives you anti-censorship incentives.
Yeah.
It still feels much less clean to me than not using entropy at all, because like I will like immediately you get an immediate disincentive to skip blocks.
That's pretty illiquid, though, right? I mean, the people, they don't have access to their funds for a long time.
Oh, but I mean that's just like that's just the role of validators. I mean their whole role is to like, lock their things down for a long time.
Yeah, I mean, I think we should be very explicit that the role of staking is to be a savings account and not a spending account. And like people are familiar with those concepts, and in general, there are lots of like Ether hodlers who are perfectly fine with that. So, like, I think we should market staking more to the sorts of the sorts of people who kind of are interested in any kind of long-term stake of some kind. Then and people who might decide they need to spend all their Ether on something tomorrow.
So how does that compare against mining?
Mining's very similar, actually. Mining is a long-term deposit. In fact, you can never get your deposit back. All you get is just the revenue stream.
Right, but here you don't get the revenue stream either, right?
No, you do. Because sorry. Actually, never mind. So there's a couple of approaches, right? One approach is you get your revenue stream when you get everything when you withdraw. The other approach is we can have the revenues kind of trickle back to you over time, and you get your principal back when you withdraw. I'm theoretically fine with both options.
Yeah, I think the latter option is going to be much more attractive to the market, right?
Okay. Yeah. No. If the latter option is more attractive, then I'm perfectly happy with it. Like I have no opinion either way.
Okay, but about the round robin versus private randomness thing, I'm still trying to like narrow down on what trade-offs we're making. To me, it seems like private randomness is better for DOS protection and for not being able to know who's going to be making what stretch of blocks in the future. So that could like potentially, better for the applications.
Yeah. Well, wait, hold on. You're saying it's better for the applications if you don't know who's going to create blocks in the future, or if you do?
If you don't.
Right. Okay.
I mean, or more specifically, it's better if you know that it'll be random.
Yeah.
Because then you don't need to worry about like making super duper long, commit reveal periods.
Exactly.
But the flip side is that you don't. So there's like with the round robin, it's like a very clear thing where like, if like I know which block I'm skipping, and I have an incentive to wait until I have like until a certain point before publishing my block. And the person whose block is skipped is going to be punished for that, and so is everyone else.
Right.
And so and they can be punished like immediately. Whereas in your version, all of these punishments have to be delayed for when the hashes end up becoming available.
Yes.
or if they don't, they have to be assumed.
Yeah, exactly. I mean, the thing is that the reason I'm not too worried about this stuff is because like each and every one of these individual punishments is probably going to be relatively small percentage-wise. So it's
But it has to add up to a large punishment for censoring and validators.
agreed. Yes. So, but my point is that like even if you take the stupidest possible approach and you just do it probabilistically, so if a validator makes smaller blocks than makes fewer blocks than their expected value, then they get punished, and everyone gets punished. If a validator gets more than their expected value, they get rewarded. Even if you take that approach, that creates a bit more variance, but it still basically accomplishes the goal. Because if, let's say, during the withdrawal period, you get a validator would on average make, I don't know, 10,000 blocks, then the standard deviation is 100, and so in the sort of extra variance you get out of that is basically just like around 1%, and if you censor more than 2% of someone's blocks get censored, then everyone get punished from that much more than they would get punished by random chance.
Sure, yeah, I totally do. I mean, I think that that's definitely true. On average, over the long run, it's quite easy to come up with mechanisms that give the same effect.
Yeah.
The only thing I'm trying to identify is whether we lose something from the immediate.
Okay.
Immediacy, and if we don't, and if I become satisfied that it's totally cool to leave these penalties and payouts for later, then I will be like down to have the private randomness thing because I think it's good for applications.
Okay.
But
yeah,
the other thing I'm thinking about is the queuing.
Oh, right. So my general argument is basically that people's money is locked in until later anyway. So if we want, like, here's a sort of mathematical transformation you can make. In the client software, when you show someone how much money they have in their deposit, what you could do is instead of just showing the amount that gets shown that's in the contract, you would actually calculate how much money they would get back if they were to go through the withdrawal procedure. And so from their point of view, as soon as they get censored or someone else or whatever happens, then they immediately see the reduction in their deposit now. And I would argue that from the point of view of both what they see and from the point of view of what eventually happens on chain, which is that they get some particular amount of money after X months, the effect is the same.
But actually, if the clients are computing the weighting of the validators,
right? Yeah.
Based on what they see, and you want the clients to actually calculate payoffs.
Well, so
like binary slashing of it.
Validators can easily calculate what their own payouts are and what the payouts of the other validators are. Not so much. Clients don't really need to look at details as much, I think.
Okay, so clients will just assume the initial distribution of stake.
Yeah. Well, actually, yeah. I mean, it could get a bit more nuanced. So, for example, one thing that you could do is, if you get evidence that some validators' deposit actually should be slashed by a lot, then you can start incorporating it immediately.
Right. Yeah. So that's a whole other stream of thought.
Yeah, that's client optimization. I'm gonna let the Python coders figure that out.
Interesting. Yeah, I kind of like that, but I also want to, give clients something to work with.
Right.
So there needs to be kind of a validator explorer, right, where people can see up to date, understanding what the distribution is on the validators.
Agreed.
I need to go. It's like 11, and I have another call right now. But
yeah, I also have another call right now. What a coincidence.
We're not having a call with each other though, so that's actually a coincidence in an even bigger way.
Okay.
All right.
So, but actually, I feel like this conversation was like, too short. We should continue it.
Yeah, completely. Okay, I'm gonna drop off now because I'm getting called on Skype like literally now.
Okay, bye.
Ciao, guys.